Welcome. This video is a tutorial on how you measure voltage, resistance, and current in a DC circuit. First off is voltage. Here you have a Fluke 79 Series 2 multimeter. To use this meter, we must first make sure that the leads are plugged in correctly. As you can see here, this is the correct way to plug in this meter for voltage. There's a common slot for the negative lead, and the positive lead goes here. With this particular meter, the leads are plugged in the same way for measuring voltage and resistance, but the dial over here must be switched to specify that you're either measuring voltage or that you're measuring current. Here I have it set up to measure voltage. So now we have the circuit. There's a 10-volt power source powering it. To measure this applied voltage, we can simply put the meter across the power source. Negative in the ground, and the positive lead in the positive. Here we can see that it is indeed almost 10 volts. Getting a negative voltage reading on a simple circuit like this isn't a very big deal, but becomes important with more complex circuits, so it's a good idea to get into a habit of hooking up the right way. An example of getting a negative power, a negative voltage reading would be like this. So as you can see, there's a negative on the left side of the meter display. Now, we already knew that this battery was going to have 10 volts before we measured it, and measuring it was very easy. So what if we wanted to measure the voltage of an individual part of the circuit that we didn't know how much voltage was across it? Lucky for us, the voltage is the easiest of the three to measure, of the three voltage, resistance, or current to measure. All we need to do is take the leads of the meter and put them across the meter like this. Put them across the component, sorry. Here you can see that this 100k ohm resistor is getting 3.305 volts. As you can see, that you can also see that there's a negative, this is a negative reading because the polarities of my leads are in opposite. This gives you the individual voltage across this component. It will also be referred to as the voltage drop or IR drop. Remember that voltage will be constant in a parallel circuit, but not in a series circuit. Now we will measure resistance. To do this, my meter is already plugged in correctly, and all I need to do is move the dial to resistance. We will measure the resistance of one of these resistors, but first we must make sure that the voltage source is off the circuit. You should never measure resistance with the power on in the circuit. Now we can measure resistance. Keep in mind that resistors have no polarity, so no matter what lead you put on what side of the resistor, you will get the same reading. As you can see, this resistor is indeed 100k ohms. You can't really see the K, but there's a K in the bottom right there. Now for the most difficult one to measure, current. When we want to measure current, we must first change where the leads are placed on this meter. Depending on where you might what you might expect to read, there's a 10 amp and a 100 milliamp position for this meter. The 10 amp is a good range to start with and move to the 100 amp one. It's actually a 40 milliamp one here, if you want more accuracy. We also need to move the dial to measure DC current, so I'll do all this right now. So I'm going to move the lead from the voltage and resistance spot, and we're going to go to the 10 amp thing, and we'll also go to the amp for on the dial. Now with voltage and resistance, simply hooking up the leads across what we wanted to measure was the correct way to measure what we wanted to get. However, now we need to hook up the meter in series with what we want to measure. So for instance, if we wanted to get the total current in this circuit, we would have to find the current between this point right here and this point right here, because this is where the side of the battery is going to the battery. Or this is where the wire is going to the positive side of the battery. However, we can't just put it across these two wires, but first we need to take it out of the circuit so that it is disconnected. The circuit looks to be disconnected because it is, but what you're going to do with your meter is you're going to basically connect the circuit with your meter so that it completes the circuit, which will also be measuring current. current. By placing the meters there, you can see that my meter isn't measuring anything. This is often because of if you're on the because I'm on the 10 amp range. It's a very wide scale, so it's not gonna be able to pick up very low current readings. So I'm going to take the lead out of the 10 amp range and put it in the 40 milliamp range. And now I'll put my leads across the same spot, and you can see here that there's 0.33 milliamps across, or flowing through this these points here that I'm putting my probes across. As you can see, this is where I put them. I put the leads every time if you didn't see it before. So there you have it. That is how you measure voltage, resistance, and current. Remember that this is how you measure these settings with this particular meter. Other meters can require slightly different steps, but they will be about the same. Also note that if you were to simply hook up while trying to measure current, as you were with voltage and resistance, you would most likely blow out the fuse in your meter, which would want to be avoided, because then you'd have to your meter would not be able to work on current anymore, and it would be you need to go buy a new one. Okay, thank you for watching.